Today we want to start solving some triangles using the ambiguous case of the law of sines. This is when we're given two sides and the angle opposite one of those sides. So called side-side angle, because we don't want to spell it the other way. Two sides and a non-included angle, the angle opposite one of those sides. Last time we talked about why this was an ambiguous case. This given set of information, this set of given information can produce 0, 1, 2, or 1 triangle. I know I said 1 twice, but that first one, 0 triangles, then there's 1 triangle, that's a right triangle. That's a Goldilocks case. If I start giving you sides that have like square roots in them, because they're exact, I'm kind of wanting things to work out. And that's like 30, 60, or 45. That's kind of like your 1 right triangle case. It's hard to land on. So there are 0, 2, 1, 0, 1, 2, or 1 triangles. There are 0 triangles if the side opposite the given angle is too short to go from the end of the other given side to the line where the third side goes. Down here is the line where the third side goes. If the side opposite the given angle is too short, that is less than the height of the triangle, then we will have no triangle. If the side opposite the given angle is less than the height, then we have 0 triangles. So if the side opposite the given angle is less than the height, no triangle. The referee will make a triangle with his hands and shake his head no. No triangle. Ruling on the field, no triangle. There's 1 right triangle when the side opposite the given angle is equal to the height. So if the side opposite the given angle is equal to the height, then we have 1 right triangle. If the side opposite the given angle is greater than the height, but less than the other given side, then we end up with 2 triangles. So if the side opposite the given angle is greater than the height, but less than the other given side, then we have 2 triangles. And then we back down to 1 triangle if the side opposite the given angle is greater than the other given side. If we look at where the height is making a right triangle. So the height is opposite the given angle. And if we have that height labeled there in a right triangle, then the other given side is the hypotenuse. So in the case, if we want to figure out what the height is, we could say that the sine of the given angle is opposite, which is the height, over the other given side, which is the hypotenuse. So one thing that we can do when we're solving an oblique triangle in the ambiguous case of the law of sines, we can calculate the height first and then decide what case we're in. So the height is the other given side times the sine of the given angle. So one strategy for dealing with the ambiguous case of the law of sines, we've got an opposing pair, A and alpha, and another side, that's the ambiguous case. We can calculate the height. Take the other given side and multiply by the sine of the given angle, and then compare the side opposite the given angle to that height. Clearly, if we're in the last one, the side opposite the given angle is greater than or equal to the other given side. We're not worried about the height. We already know there's one triangle. But if we have an acute angle and the side opposite the given angle is less than the other given side, we're going to need to know the height to know how many triangles there are. So one strategy that we have is to calculate the height to determine the number of triangles. The one that we have to be most concerned is what do we do when there's two triangles? How do we cope with two triangles? So let's deal with a two triangles case. So let's set up an ambiguous case of the law of sine. This is where I give you one angle and two sides, and one of those sides has to be opposite that given angle. Let's suppose that beta is 36 degrees. That means I'm going to have to give you a B, not for a grade, although some of you will be getting a B, I'm assuming. I don't know, maybe I'll just flunk everybody. No, I have trig next. I think I have trig in the fall, so everybody come back and be all mad at me. Or maybe you wouldn't take the teacher that flunked. I don't know. I don't know how you would react to that. Would you come back for revenge? Would you come back to prove yourself, or would you just avoid me? I just don't know how it's going to go. It's part of the reason I can't eat at restaurants in the local area. because one of you might work at the restaurant. So I like walk in, I sit down, and you're like, oh, hey, Professor Leach. I'm like, oh, you work here? And you're like, oh, yeah. It's like, well, let's have water for now. And then as soon as you walk away, I'll tell my wife, like, all right, Kath, you gotta get the heck out of here. She's like, oh, why? Because that's one of my former students. And she says, so I don't remember what grade they gave him. So we gotta get out of here. You know what I mean? I'm just kidding. I don't do that. All right. So I just got to give you a side opposite this given angle and another given side. So let's give you another given side. That's A or C. Let's use C because I used A and alpha a lot last time. So C, which is going to be the other given side, is going to be, I think it's 17. And then I have to give you the side opposite the given angle, which is going to be a value of B. I don't want this to just work out randomly. I don't want this to work out just randomly. I don't want to pick one at random. I want to make sure that I get the two triangles case. So I need to know. We're going to watch this problem get created. I need to calculate the height so I know where to put B to make sure that I get two triangles. The height is going to be 17 times the sine of 36. And so the height of this triangle, it looks like 10, 9.99. If I make my side opposite the given angle less than 10, I'm going to get no triangle. If I make it exactly equal to this, then I'll get one right triangle. That's going to be hard to land on. I don't want to say C is 9.99234929. That would be just a dead giveaway. It's like, oh, you're trying to make one right triangle, aren't you? And I'm like, oh, yeah. And they go, well, tough luck, sucker. I'm using my iPhone for a calculator, and it has more digits than that. So I've ruined the whole game. So I just need to make it bigger than 10, but still less than the other given side. So somewhere between 10 and 17. So let's make B equal to 12. And now we're for sure going to have two triangles because we need to know how to deal with that. So one strategy is to say, I want to know stuff. I don't want to just go into this blindly. I'm going to calculate the height so that I could see how many triangles we have. So I'm going to employ the strategy of calculate the height. So the height got to make sure that I get the other given side and the given angle. I don't want to use 12 sine 36 because 12 is opposite the 36. So the height is going to be the other given side times the sine of the given angle. So when we round this off to the nearest tenth, I get 10.0. So the side opposite the given angle is greater than the height, but less than the other given side. So two triangles. Soga is 12. That's that's greater than the height of 10 and less than the other given side So this is going to do what I want it to do. And now you've seen how I write these problems. So when quiz, I don't know which one's going to go. When the next quiz, which will be equal to 1 modulo 4, shows up, this is how I write it. I pick an angle, that's acute angle. Then I pick the other given side, I decide how many triangles I want you to solve for, 0, 2, or 1. And I just get the side opposite given angle the appropriate length. This is the two triangles case. We need to know how to deal with that. Let's start by finding the first thing that we have to find. I have an opposite pair, so I'm going to use the law of sines. So I'll say the sine of 36 over b, or 12, sine of beta over 12 is equal to the sine of gamma over c. I just set up my law of sines. And I'm going to use this to solve for gamma. So gamma is going to be the sine inverse of 17 sine 36 divided by 12. It's just a proportion, so I multiply both sides by 17. Put the 17 on this side, then do a sine inverse. So I take 17 sine 36 and divide that by 12. Oh, convenient. I could have just said divided by 12. And that's 0.833, we'll call it. Am I in radians? Oh, I'm in degrees, but I forgot to say sine inverse. Sine inverse of 17 sine 36, close parentheses, divided by 12, close the parentheses. And I get 56.4 degrees. And right now we're thinking, dude, that is one angle. We needed two angles. So what we're going to do is we're going to recognize that sine is positive in the first and second quadrants, and angles in the second quadrant will fit into a triangle as long as the other given angle, as long as the given angle is an acute angle. So I'm just going to take the 56.4 degrees, and since it's the two triangles case, I'm going to put 56.4 in quadrant 1 and quadrant 2. Since it's two triangles, that's how we get two triangles. We put it in quadrant 1 and quadrant 2. So my gamma in quadrant 1 is just going to be 56.4 degrees. My gamma in quadrant 2 is going to be 180 minus 56.4. $123.6. And now the problem has just been split in half. And I just solved one triangle from the quadrant with the quadrant 1 and my quadrant 2 triangle. Now that I have two angles, I need to subtract to find the third angle. So my alpha in alpha from quadrant 1 is going to be 180 minus the 36 minus 56.4. So that's going to be 87.6. And my other alpha will be 180 minus 56.4, oh, minus 36, excuse me, minus the 123.6. And finally, we just need to solve for A. There's two different ones. 56 in quadrant 1 and then 56 in quadrant 2. I'm going to use the given information of sine beta over B. Because I like to use given information because this stuff has been rounded off. I can't avoid using this rounded information. But I'm going to say sine of 36 over 12 is sine of 87.6 over A. So my first A is 12 sine 87.6 divided by sine of 36. I'm actually going to go back up and grab the whole thing. That's the 56. And I do 180 minus 36 minus this value. So instead of 87.6 all rounded off, I'm going to use 87.62 and then all that other stuff. So I'll take 12 sine of that angle, close parentheses, divide by the sine of 36. That way, none of the stuff that I'm using has been rounded off. And so it looks like A is 20.4. What a horrible coincidence that A is equal to A1 is equal to alpha 2. That is just a coincidence. They are not, they have the same value, but they are completely different things. This is a length, that's an angle, so they can't be equal. They are not the same. Just because the number is the same doesn't mean the things are the same. 20.4 length units is not the same as 20.4 degrees. Same value thing totally doesn't work. Walked into the Ferrari dealer. I said, here is $1, and I would like to trade it for 1 Ferrari. They're the same number, so it should be a straight trade, right? That's how to get thrown out of a Ferrari dealer, which I think is the correct answer. I think that's the appropriate thing to have happen, to get tossed out, like forcibly removed by security. The other way to do this is to go in there, get dressed up a little bit. Actually, no, if you're in California, just wear a hoodie. They'll think you're a tech billionaire. I'm too old to look like a tech billionaire. Just walk in there and sit in one of the most expensive Ferrari you can find and just start making car noises. Uncle, sir, can I help you? And you're like, oh, no, I'm fine. That's the important part of it. You don't be like, oh, yeah, I'm considering buying this car and all that other stuff. It's like, oh, no, I'm fine. And then just go back to what you were doing. That's another way to get thrown out of a Ferrari dealer. Also, fun fact, works on Lamborghini dealers. They do it with less style because even though it's a Lamborghini, Lamborghinis are just Audis. And so they have like a German seriousness to them. So I'm just kidding. I've never been thrown out of an exotic car dealer. Not anyone knows that. So now we got to go over to the other side and do the same thing. I'm going to take the sine of 36, divide by 12, and that's going to be the sine of 20.4 divided by the other a we're looking for. So it's going to be 12 times the sine of 20.4 degrees over the sine of 36. Now, I'm not going to use this 20.4 because it's a different 20.4. If I want to get at the other 20.4, I got to go through a couple of hoops. I got to grab my original reference angle. I got to put it in the second quadrant. I got to subtract 180 minus 36 minus this angle. So you can see that this is a different 20.4 entirely. And now I'll do 12 times the sine of that angle, close parentheses, divided by the sine of 36, close parentheses. And that side is 7.1. So there are our two triangles. If beta is 36, C is 17, and B is 12, then the other alpha is 56.4. Sorry, the other gamma is 56.4. The other alpha, one of the alphas is 87.6, and that alpha is 20.4. If I take that 56.4 and put it in the second quadrant, I get a 123.6, which gives us a third angle of 20.4, which gives us that third side of 7.11. That's how you deal with the two triangles case. That first angle that you find, just put it in the two quadrants, in the first and second quadrant. That's the strategy. In the two triangles case, put that angle in the first and second quadrants, solve both of those triangles. Okay. How's everybody okay? Let's do a zero triangles example. Let's suppose that beta is still 36. 36. Let's suppose that C is still 17. And let's suppose that B is 8. We know from before that 17 sine 36 is going to give us a height of 10, and B is now less than that height. So we know we're looking at no triangle. So one strategy is to calculate the height. And the height is going to be 17 times the sine of 36. And we know from before that this is 10, but we're pretending that we don't know that. So in this problem, just by calculating 17 sine 36, we get a height of 10. The side opposite the given angle is less than the height. So there is no triangle. Ruling on the field, no triangle. Here's what I want to do. I want to pretend that we forgot to calculate the height. We forgot that we should calculate, or we forgot that we could do this and determine how many triangles we're looking at. Let's just go into the problem and start trying to solve. What if we didn't notice this? What if we didn't notice the zero triangles thing? What if we just didn't notice that there were zero triangles and we went and started to try to solve for gamma? So we'll do sine of 36 divided by 12, divided by 8 is equal to the sine of gamma divided by 17. So that means that gamma is going to be the sine inverse of 17 sine 36, the height, divided by 8. So we grab our calculating machine and we do the sine inverse of 17 sine 36 close parentheses divided by 8 close parentheses equals, and we get a domain error. Calculator's like, oh no, pay more attention. Specifically, we have a domain error. That's the important part. If it was an error that said syntax, if it was a syntax error, that just means we typed some nonsense at our calculator and it didn't understand what we were trying to say. But a domain error is because if we calculate that height divided by the 8.0, that's more than 1. So what we want to notice here if we get rid of the sine inverse part. So this kind of error means we're just talking to the calculator wrong. This error is a syntax error. The calculator's like, I don't understand what you're trying to ask me. And then we'll see that there's a hanging parenthesis there. So the 17 sine 36 divided by 8 is 1.24. And the important thing here is that this 1.25 is greater than 1. No angle has a sine greater than 1. We can't have the sine of an angle be greater than 1. That would mean that the opposite is bigger than the hypotenuse, and that can't happen. The side opposite can't be greater than the hypotenuse. That's why there's no triangle. The height is too much. The ratio of the height to the side opposite the given angle is 1.25. The side opposite the given angle would have to be 25% bigger just to make it to the line where the third side goes. So if we didn't notice that it was 0 triangles, our first attempt at calculation would show us that it's 0 triangles. Question? I still recommend that you calculate the height and make the comparison, because it's a little bit easier. Just saying error, we got an error, so no triangles, doesn't rule out the possibility of doing a syntax error when there are more than 0 triangles. Questions? Let's take 5 and come back and do one more example. Let's do the side opposite the given angle is greater than the other given side. All right, take 5, and then come back.